Hi, my name is Krista Wells and welcome to my video on creating and interpreting box plots using SPSS. Often when we give benchmark assessments, we want to get an idea on how the test scores are distributed and identify any outliers that may be in those variables. Box plots can help us analyze our test score data. I am going to upload an Excel sheet of fictitious benchmark assessment test scores for an ELA 11 class. There are two classes, period 1, which is in the beginning of the day, and period 10, which is at the end of the day. There are a total of 20 students in each variable. So I'm going to choose open another file, and I'm going to just choose Excel data, and then choose benchmark assessment scores. Now, as you could see here, I have my two variables, period 1 ELA 11 class and my period 10 ELA 11 class. And this is their benchmark assessments. I just want to compare how the period 1 class did compared to the period 10 class. So the first step I'm going to do is I'm going to click on Analyze, Descriptive Statistics. I'm going to click on Explore. I'm going to choose my two dependent lists, which is period 1 and period 10 variables. I'm going to click on Statistics, and I'm going to make sure I choose Descriptives, and I'm going to choose Outliers and Percentiles. Click Continue. For plots, I'm going to uncheck stem and leaf. Click Continue. And for options, we're just going to leave it as is. Click Continue. And then we're going to check OK. Here we have the descriptives for both period 1 and period 10 test scores. You can see the mean average for period 1 is 69.3, and for period 10 it's 80.5. So we could see that the earlier class scored lower on the test than the afternoon class at 2:20 p.m. Now if I scroll down, I want you to pay attention to the row that states Tukey's hinges. As we could see under Tukey's hinges, the quartile 1 level for period 1 is 60. And for period 10, it's 76. For quartile 3, which is the 75%, for period 1, it's 86.5, and for period 10, it's 91.5. So the interquartile range for period 1 is 86.5 minus 60, and that equals 26.5. For period 10, the interquartile range would be, again, Q3 minus Q1, 91.5 minus 76, which is 15.5. As we move down to the box plot for period 1, the line in the middle is the median value, which is quartile 2, and it is situated at 71. The rectangle, which you see here, extends from the bottom, which is quartile 1, and you can see that quartile 1 is set at 60, all the way to the top, which is quartile 3, which is set at 86.5. And we saw that in the percentiles under Tukey's hinges, 60 and 86.5. Quartile 1, quartile 2, quartile 3. Now you will observe the whiskers. The highest value in the dataset is represented by the top whisker, and it is set at 99. The lowest value in the dataset is represented by the bottom whisker, and it is set at 21. Now, the whiskers exclude outliers. From visualizing the box plot, we can deduce that the bottom 25% of the values lies between 21 to 60, as seen from the bottom whisker to quartile 1. The top 25% of the values lies between 86.5 to 99, as seen from the top whisker to quartile 3. The middle 50% of the values lies between 60 to 86.5. That's from quartile 1 to quartile 3. The median, which is quartile 2 line, is situated closer to the lower quartile, quartile 1, indicating that the lower half of the values is grouped closer to quartile 1 than quartile 3. Now, as you can see here, for period 1, we have one outlier included at the bottom of the box plot. We see record 15, and there's a circle next to it. Now, as you can see, SPSS divides outliers into categories on a box plot. The circle outlier is a mild outlier. If we had an extreme outlier, we would have seen a star shape next to the record and not a circle. If we look at record 15, under period 1, we will see a score of 16.